नमस्ते विद्यार्थी मित्रांनो, आज आपण नवीन एक लेसन चालू करतोय 12th स्टँडर्ड केमिस्ट्रीचा. लेसन नंबर 8, ट्रान्झिशन अँड इनर ट्रान्झिशन एलिमेंट. आता हा लेसन खूप मोठा लेसन आहे, ट्रान्झिशन अँड इनर ट्रान्झिशन एलिमेंट. पण त्यातल्या आपण कॉन्सेप्ट आज समजावून घेणं खूप महत्त्वाचं आहे आणि त्यासाठी आपण आजच्या भागामध्ये पहिल्या 6 कॉन्सेप्ट आपण समजावून घेतोय. ट्रान्झिशन अँड इनर ट्रान्झिशन एलिमेंट, त्याच्या फर्स्ट 6 कॉन्सेप्ट. ह्या 6 कॉन्सेप्ट समजावून घेण्याच्या अगोदर हे ट्रान्झिशन एलिमेंट अंदाजे पिरियडिक टेबलमध्ये कुठं असतात, लेट अस सी. तर पिरियडिक टेबल जर आपण बघितलं, इन पिरियडिक टेबलच्या लेफ्ट हँड साईडला हिअर पिरियडिक टेबल इज देअर. पिरियडिक टेबलच्या लेफ्ट हँड साईडला एस ब्लॉक एलिमेंट्स आहेत. पिरियडिक टेबलच्या राईट हँड साईडला पी ब्लॉक एलिमेंट आहेत. आणि एस ब्लॉक एलिमेंट आणि पी ब्लॉक एलिमेंट त्याच्यामध्ये जे डी ब्लॉक एलिमेंट्स असतात आपण त्यांना म्हणतो ट्रान्झिशन एलिमेंट. ओके, ट्रान्झिशन एलिमेंट ही कॉन्सेप्ट आधी क्लिअर व्हायला पाहिजे की ट्रान्झिशन एलिमेंटची जागा कुठे आहे. व्हेअर इज द प्लेस ऑफ ट्रान्झिशन एलिमेंट इन द पिरियडिक टेबल. तर पिरियडिक टेबलमध्ये the place for transition element is given in between S block element and P block element, and therefore the D block elements are called as a transition element. हे महत्त्वाचं आहे because the place of transition element, place of D block element is given in between S block element and P block element. Therefore D block elements are called as ट्रान्झिशन एलिमेंट. हे सुद्धा एक्सप्लेनेशन कधी कधी विचारलं जाऊ शकतं की डी ब्लॉक एलिमेंटला ट्रान्झिशन एलिमेंट्स असं का म्हणतात. तर त्याचं एक्सप्लेनेशन ते एस अँड पी ब्लॉक एलिमेंटच्या मध्ये असतात, त्याच्यामुळे त्याला आपण ट्रान्झिशन एलिमेंट असं म्हणतो. सेकंड कॅरेक्टरिस्टिक आपण डिस्कस करायची म्हटली ट्रान्झिशन एलिमेंटची किंवा डी ब्लॉक एलिमेंटची, तर इलेक्ट्रॉन. इलेक्ट्रॉन एंटर्स इनटू n-1 डी शेल. हा जो ट्रान्झिशन एलिमेंटमधला जो इलेक्ट्रॉन असतो तो एंटर कुठं करतो, तर n-1 डी सबशेलमध्ये, n-1 डी शेलमध्ये, आणि त्यालाच आपण पेनाल्टिमेट शेल असंही म्हणतो. हे 2 पॉईंट आपण इथं त्याच्या कॉन्सेप्ट क्लिअर केल्या पाहिजेत. लेट अस स्टार्ट. पहिली कॉन्सेप्ट आहे 3D आणि 4D लेवल. म्हणजे 3D लेवल त्याचे एलिमेंट 10 आहेत आणि 4D लेवल त्याचे सुद्धा एलिमेंट 10 आहेत. राईट ए शॉर्ट नोट ऑन एलिमेंट्स ऑफ 3D लेवल आणि एलिमेंट्स ऑफ 4D लेवल. म्हणजे 3D लेवलचे एलिमेंट्स 10, 4D लेवलचे एलिमेंट्स 10, त्याची फक्त नावं किंवा इंट्रोडक्शन लिहा, असा एक सिंपल क्वेश्चन असू शकतो. मग आपण 3D लेवलचे लेट अस अंडरस्टँड 3D लेवल. 3D लेवल SC, स्कँडियम atomic number 21, टिटानियम atomic number 22, वॅनाडियम atomic number 23, क्रोमियम atomic number 24, manganese atomic number 25, iron atomic number 26, cobalt atomic number 27, nickel atomic number 28, copper atomic number 29, and zinc atomic number 30. So these are the 10 elements which belongs to the 3D series. Now let us see the elements which belongs to the 4D level. Elements are yttrium atomic number 39, Zr zirconium atomic number 40, Nb niobium atomic number 41, molybdenum atomic number 42, technetium atomic number 43, here ruthenium Ru atomic number 44, rhodium atomic number 45, palladium atomic number 46, silver atomic number 47, and cadmium atomic number 48. So just we have seen which elements belong to the 3D block, otherwise 3D group, and which elements belong to the 4D group. So these are the simple introduction regarding with the 3D block element and 4D block element. This is the point number first. Sometime they are going to ask that, okay, write a short note on 3D block element and 4D block element. Okay, so this is the first concept. I hope it is clear. Concept number 2, general electronic configuration of D block element. General electronic configuration you are going to write. General electronic configuration. So as you know that, okay, 3D block element, 3D, 4D, D block element. D block elements are categorized into 3D block, 4D block, 5D block, and 6D block. Okay, D block elements, 3D block elements, 4D block elements, 5D block elements, and 6D block element. Okay, out of that 3D, general electronic configuration of 3D block element. First we have to write argon. Okay, so argon, in front of argon 3d level, and d level contains 1 to 10 electron. Here forest level contains 2 electron. So this is the general electronic configuration of 3d level. Then general electronic configuration of 4d level. 4d we have to write, then krypton we have to write. So bracket complete, outside bracket 4d level, it contains 1 to 10 electron. 5s level it contains 0 to 2 electron. So this is the general electronic configuration of 4d level. Next, general electronic configuration of 5d level. How we are going to write 5d? Then xenon, then outside the bracket 5d level, it contains 1 to 10 electron. Then 6s level, it contains 2 electron. And last 6d level. 6d level, first we are going to write radon into bracket Rn, radon. Outside bracket 6d level contains 1 to 10 electron, and 7s level contains 2 electron. So whatever we are observing, 3d level, this electronic configuration, 4d level, this electronic configuration, 5d level, this electronic configuration, 6d level, this electronic configuration. So this is called as general electronic configuration of D block element. So this question will be separate question, that write a short note on general electronic configuration of D block element. For that, this much answer we are going to write in the examination. Then next question, next point, next concept number 3rd, electronic configuration of chromium and copper. Okay, electronic configuration of chromium and copper. Let me tell you, 3D block elements are there. So out of that 3D block element, chromium is one element. Here you can see chromium, and copper is another element. So electronic configuration of chromium and copper, it has very vital importance. Okay, electronic configuration of chromium and electronic configuration of copper, so it has importance. Okay, so let us see that chromium and copper. Pay attention there. Electronic configuration of chromium and copper. What is the atomic number of chromium? Atomic number of chromium, that is a 24. Then how we are going to write electronic configuration? Argon. Then 3d level, chromium contains 4 electron. 4s level, chromium contains 2 electron. Okay. Then atomic number of copper is 29. How we are going to write electronic configuration? Argon. Then 3d level, copper contains 9 electron, and 4s level, copper contains 2 electron. This is electronic configuration, but this is expected electronic configuration of chromium and copper. Expected electronic configuration. But observed electronic configuration is different. What happens in case of observed electronic configuration? One electron from 4s level is shifted to the d level. So here d, one electron is shifted from 4s level. So 4 plus 1, 5. So d level, it contains 5 electron, and 4s level, it remains 1 electron. So copper, observed electronic configuration, 3d 5 and 4s 1. 3d level, 5 electron, and 4s level, 1 electron contains by copper. So this is the observed electronic configuration of copper, and that is important. Chromium, atomic number 29, we have seen expected electronic configuration, that is the 3d9 4s2. But okay, what happens here? 1 electron from 4s level is get shifted to the d level. Okay, then 9 plus 1 here becomes 10. 3d level, it becomes a 10 electron. 4s level, it becomes 1 electron. So this is the observed electronic configuration of copper, and these two observed electronic configuration of chromium, observed electronic configuration of copper is important for us. So it may go for 2 marks. Write electronic configuration of chromium and copper. So this is the concept number 3. Then concept number 4, oxidation states of 3D block element. Let us see that. Write a short note on oxidation state of 3D block element. Okay, 3D block element, let me tell you: scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. So these elements are belonging to the 3D block. So let us see oxidation states of 3D block element. Okay, As I told you, scandium, titanium, vanadium, chromium, manganese. In this way we are going to write iron, cobalt, nickel, copper, zinc. In this way, half section we are going to write scandium up to manganese, and in front of that iron up to zinc. Then let us see how we are going to write oxidation state of 3D block element. Scandium plus 2 plus 3, titanium plus 2 plus 3 plus 4, okay, vanadium plus 2 plus 3 plus 4 plus 5, then chromium plus 2 plus 3 plus 4 plus 5 plus 6, and manganese highest plus 2 plus 3 plus 4 plus 5 plus 6 and plus 7. So this is the highest oxidation state shown by this manganese. This point you have to note down. Then iron, oxidation state plus 2 plus 3 plus 4 plus 5 plus 6. Now oxidation states are decreases. Here increases and here decreases. Cobalt plus 2 plus 3 plus 4 plus 5. So it is a decrease. Nickel plus 2 plus 3 plus 4. Copper. Here copper, in case of copper, plus 1 and plus 2. Here you cannot see plus 1 oxidation state belongs to scandium up to zinc. In case of copper only, copper belongs plus 1 oxidation state. So oxidation state of copper, that is plus 1 and plus 2, and zinc plus 2. So here iron, cobalt, nickel, copper, zinc, oxidation state you can answer, it is decreases. And in case of scandium, titanium, vanadium, chromium, manganese, so oxidation states are increases. So this is the oxidation state of 3D block element. So this is point number 4 we have cleared. The next point number 5th, write a short note on physical properties of 3D block element. How we are going to prepare, how we are going to understand this point. Physical properties of 3D block element. All are metals we have seen. Scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc. In short, okay, one short form is there, Sati Vikraman, Feco, Nico, zinc, like that, okay. You can remember, you can keep in your mind, okay, 3D block element, Sati Vikraman, Feco, Nico, zinc, Sati Vikraman, Feco, Nico, zinc. So these are the elements, physical properties of 3D block element. First, all are metals. Second, all are hard in nature. All are lustrous. All 3D block element, all 3D block metals are lustrous, means they are having shining. Malleable. All metals can be converted into sheet, that is the malleable property. All metals can be converted into wire, that is the ductile property. So all metals are hard, then they are having special type of shining. From that metal, sheets can be prepared, patre. So that is the malleable. From that, ductile means we can prepare wire, tara kadta yetat. So that is the ductile in nature. Then property number 3rd, all metals from 3D block elements, they are good conductors of heat and electricity, because in case of D block element, unpaired electrons are present. Due to unpaired electron, they are good conductors of heat and electricity. And point number 4, so this is 3D block element, they are showing high melting point and high boiling point. If we have observed melting point and boiling point of 3D block element, we can observe that they are having high melting point and high boiling point. So point number 1, point number 2, point number 3 and point number 4, these are the basic physical properties of 3D block element, Sati Vikraman, Feco, Nico, zinc. Okay. Then last point, last concept of today's session, atomic radii. This point you have to see, listen very carefully, because this is important point, important concept. Atomic radii. Atomic radii, okay, let us see the definition of atomic radii. Atomic radii can be defined as distance from nucleus up to the last orbit of an atom. So this distance is a measure, that is atomic radii. Regarding with the atomic radii, we are going to take information. Okay, atomic radii. What happens in case of 3D block element? Regarding with the atomic radii, point number 1, listen carefully, see carefully. Atomic radii decreases from left to right, means scandium, titanium, vanadium, here chromium, manganese, iron, cobalt, nickel, copper, zinc. As we go from left to right side, atomic radius decreases. This is first important point. In case of atomic radius, what happens? Atomic radius decreases from left hand side to the right hand side of 3D block element. For example, one example we will give. In case of scandium and titanium, scandium have 164 pm atomic radius of scandium at M level. Okay, when scandium loses one electron, that time the atomic radius of scandium is 164 pm. And M plus 3 level, atomic radius of scandium, that is a 73. So as we go from left hand side to the right hand side, we can observe that atomic radii decreases. Here 164 decreases 73 picometer. In case of titanium only, atomic radius of titanium first 147 pm at M level, and it becomes 67 pm at M3 level. So here we can conclude that atomic radius of titanium also decreases from left hand side to the right hand side. Why there is a decrease in the atomic radii? So explanation we have to see in point number 3rd. As atomic number increases, here we can see scandium 21, 22, titanium, vanadium 23, chromium 24, manganese 25, iron 26, cobalt 27, nickel 28, like that. Okay. So as atomic number increases, effective nuclear charge increases. As atomic number increases, the effective nuclear charge increases. And effective nuclear charge increases. Due to that effective nuclear charge, there is decrease in the atomic radii. So this is one of the important property, you can say important point regarding with the atomic radii of 3D block element. So this point is related with 3D block element. Atomic radii, and we have seen that atomic radii from left hand side to the right hand side, atomic radii decreases in case of 3D block element. Today this is the time to stop here. Tomorrow once again 12th standard chemistry, the same lesson number 8, transition and inner transition element, with more new concept. We will clear our concept. Thank you. Keep watching Alchemian. Thank you all of you.